So today we're going to be looking at application of trigonometric ratios, and today we're going to be looking at angle of elevation and angle of depression. Now trigonometric ratio has to do with right angle triangle, that is a triangle that has just 3 sides. So in this video we're going to be looking at how we're going to know angle of elevation and angle of depression. So we're going to be taking, for instance, I'm going to take an example. So say for instance this is your eye, right? And then you now have, say for instance, an aeroplane that is on top that you want to look at to find the angle of elevation for it. Okay, so first of all your eye has to look horizontally. That's a straight eye view that you're going to use so that you can look upwards in case to be able to ascertain the angle. So you look upwards, and then looking upwards, going like this in a clockwise direction is known as your angle of elevation. All right, so now take for instance, you now want to look down, angle of depression. You now have this like a ball, then we now want to look down, so looking downwards from the horizontal point, you now direct it there. So from that point the angle of depression is from the horizontal axis to the ball. So this angle here is known as angle of depression. This angle, all right, it's called angle of depression. Now there is one mistake that people do all the time, all right, that I've noticed. Now you see from this point downwards, this angle here is not your angle of depression. Right, so your angle of depression is from that side to here, and it goes in a clockwise direction, whereas your angle of elevation goes in an anti-clockwise direction. So we're going to take an example to know how to do angle of elevation. So say for instance, say the angle of elevation of a point P on a tower from Q on the horizontal ground, right? On the horizontal ground is 60 degrees. So we're going to draw the tower. Okay, this is the tower, this is the top P of the tower, and then to our point Q, say from Q, so we're going to draw Q. So taking the horizontal axis, so it says to the horizontal ground is what, 60 degrees. From the point Q to the horizontal ground is 60 degrees. Okay, so it says if the magnitude of P and Q is 75 meters, so we draw from P to Q, we have 75 meters. All right, so now how high is P above the ground? Okay, so this is P, this is the ground, so the height of P from the ground is what we're looking for. That is now we'll call X. All right, so we're trying to find X, which is the height of P from the ground. So now I'm going to try to redraw this diagram so that we can have an understanding of what it looks like. So we have it to be like this. So you remember in a triangle where you have opposite, hypotenuse and adjacent, that angle theta, remember our SOHCAHTOA, SOHCAHTOA, for us to ascertain, to find the angles and the heights, we have means sine theta is equals to opposite all over hypotenuse, cos theta is equals to adjacent all over hypotenuse, that's the car, and tan theta is equals to opposite all over adjacent. Right? So now we'll have to use that to be able to find our solution. So we'll compare that with the diagram that we have. So in our diagram that we have, that is our solution. Let me clean this. Okay, let's try to redraw it. So let me redraw the diagram. We have 60 degrees, we have our 75, and then we have x. So here we have our opposites, we have our hypotenuse. That means the particular one that we'll use to represent the information to find x is our that's opposite over hypotenuse, all right? So we now like sine 60 degrees is equal to x all over 75 meters. Therefore x is equal to 75 times sine 60, and that is our final answer.